They lied. This is Africa, and this is Africa on a map. Would you be surprised if I told you that Africa is actually 5 times larger than it appears on normal maps? But why? Jane Elliott has an interesting theory.
All the white countries are larger than they should be, and all the countries of people of color are smaller than they should be. This is a visual image that teaches children a lie.
That's right. It might look small, but Africa is so big that you can fit China, India, the United Kingdom, United States, Brazil, and Saudi Arabia on it. It's huge. But seriously, why would early explorers and mapmakers draw one of the biggest continents in the world as one of the smallest? What were they hiding? Or was it so difficult to draw maps that it took hundreds of years for them to get an accurate depiction? Today, we reveal the true size of Africa and other continents compared to what they teach us and unravel the story about the maps of Africa. This is a one-eyed cyclops person in what looks to be today's Nigeria. You're looking at the oldest printed map of Africa ever found, and it features an elephant in South Africa, crowns and scepters in kingdoms all over, and of course the one-eyed cyclops person. Was this a real person? We don't know. What we do know is that Sebastian Münster first published this map in 1540, more than 400 years ago. In the early days of cartography, mapmakers had limited knowledge about Africa, and as European explorers began to chart the continent more extensively in the 15th and 16th centuries, the inaccuracies persisted. Here's a modern map of Africa. In reality, Africa is colossal.
All continents put together will fit into Africa.
It's the second largest continent on Earth after Asia, spanning over 30 million square kilometers. For perspective, let's look at Russia. It appears to be massive on this map, but compared to Africa, it's not. This is because of the curvature of the Earth and the equator, which makes drawing accurate maps really difficult. The Mercator maps, developed by Gerardus Mercator in 1569, were revolutionary for navigation due to their ability to represent courses of constant bearing in straight lines. However, this projection significantly distorts the size of continents, especially near the poles. As a result, regions closer to the poles like Greenland and Africa appear much larger or smaller than they are in reality. Maps that depict Africa and other continents with distortions, such as the Mercator projection, are still widely used. This is primarily because of their historical significance, familiarity, and practical applications. It allows sailors and pilots to plot straight-line courses, which is essential for maritime and aeronautical navigation. But there are alternatives to the Mercator projection that address its limitations. One such alternative is the Robinson projection. This projection strives to balance the size and shape distortions, providing a more visually accurate depiction of land masses, including Africa. Another option is the Winkel-Tribal projection. This projection also aims to reduce distortion by providing a compromise between accurate size and shape. It's often used in world maps to offer a more balanced view of continents. And then there's the Peters projection, or Gall-Peters projection. This map emphasizes equal area representation, showing landmasses according to their true size relative to each other. The Peters projection is particularly useful for highlighting the true size of Africa, presenting it more accurately than the Mercator projection. For the most precise depiction of Earth's surface, scientists use geoid models, or 3-dimensional globes. These models show countries and continents in their true size and shape, offering the most accurate representation. However, they are more difficult to use for navigation. This is why we use a combination of all of these types of maps today. The kind of map you're using all depends on what you're trying to navigate. Did you know that the art of map making dates back to ancient civilizations? The oldest known map, created by the Babylonians around 2300 before Christ, shows the world as a flat disk surrounded by a river. This early map reflects the understanding of geography at the time. In the Middle Ages, European maps were often TO maps, which depicted the world with Jerusalem at the center and the continents arranged in a T-shaped layout. These maps were more about representing religious and cultural views than geographic accuracy. Fast forward to today, and map making has undergone a revolution. With the advent of satellite technology, Geographic Information Systems or GIS, and GPS, modern maps are incredibly accurate and detailed. Satellites orbiting the Earth provide real-time data, allowing us to create highly precise maps. GIS technology allows cartographers to layer various types of information on a single map. This means we can combine data on terrain, population, weather, and much more, all into one interactive map. Today, mapping isn't limited to traditional paper maps anymore. Mobile apps and digital platforms offer dynamic interactive maps that update in real time, helping us navigate with ease and access detailed information about nearly any location. Crowdsourcing has also transformed modern cartography. Platforms like OpenStreetMap rely on contributions from people all over the world to update and refine maps. This community-driven approach ensures that maps are continually improved and kept up to date. Comparing ancient maps to those of today highlights just how far we've come. From rudimentary drawings and religious symbols to highly accurate digital representations, the evolution of mapmaking reflects our expanding knowledge and technological advancements. Maps have come a long way from their ancient origins, and with ongoing technological advancements, the future of cartography promises even greater accuracy and innovation. Whether it's through historical maps or cutting-edge digital tools, our quest to understand and represent our world continues. So what's next? As much as we have narrowed down maps on the ground, there's still a whole universe above us, and the next step is to map all of the stars and galaxies that populate our skies. This is a colossal task because the universe is ever expanding and so vast that our human minds can't even begin to comprehend its size. So how do we do it? Millions of satellites send data and images to centers all over the world, and this data is used to project maps of our different galaxies. The furthest satellite from Earth is the Voyager 1. No spacecraft has gone farther than NASA's Voyager 1. Launched in 1977 to fly by Jupiter and Saturn, Voyager 1 crossed into interstellar space in August 2012 and continues to collect data. This way, we can map out further galaxies. However, with our ever-expanding solar system and moving parts, we might never reach a point where we have a definitive picture of the skies above. Thanks for joining us on this journey through the fascinating world of cartography. We've explored how our understanding and representation of the Earth have evolved over millennia. Don't forget to like and subscribe if you like our content. Make sure YouTube gives you more. Cheers.
This continent is the biggest continent in the world, not separated even by a river. The rivers that are there flow with the continent. They don't cut it into half or quarter. All continents put together will fit into Africa.